Hello and welcome to Geometry, Circumference and Area of Circles, including parts of circles. In this video, we will find and apply the definitions of radius and diameter to find the circumference and arc lengths, area of a circle and sector, measures in intersecting circles, and convert radians and degrees. These are some of the standards that we will have in this video. These are from the Florida's Best Standards for Mathematics. So let's go ahead and get started. In our last video, we talked about circle vocabulary. So if you haven't watched that video yet, you might want to go back and watch it. In this problem, it tells us that CP, or segment CP, is 6 centimeters. So we want to go ahead and make sure that we mark that. And then it's asking us for the radius and diameter of the circle, the circumference, and the area of the circle. Well, CP is a radius. It's going from the center to a point on the outside boundaries of the circle, and so the radius is going to be 6. Your diameter is going to be twice that, and so our diameter is going to be 12. If we were looking at BA, that means that this piece is 6 and this piece is 6. And BA is a diameter of the circle. It has both endpoints on the end of the circle and it goes through the center. So BA is also 12 centimeters. When it comes to circumference and area, you do have those on your reference sheet, but if you don't remember, it's 2 pi r, or we can use pi d. And then for area, we have pi r squared. When we go to put this in, we have 2 times pi times the radius. So in your calculator, you're going to do all of your numbers. So we've got 2 times 6 gives me 12, and then we're going to put pi at the end. If they ask for the exact answer or the answer in terms of pi, you would just leave it as 12 pi. If they ask you for a rounded version of the answer, or if they're asking you to write it to the nearest decimal, whether it's tenths or hundredths, you're going to use your pi button in your calculator unless they tell you to use something else. I know that there are some tests that are going to ask you to use 3.14 and then round using 3.14, or they're going to ask you to use 22/7. In this case, we're just going to use the pi button. So we have 12 times pi, and then here's pi here, so you make sure you hit equals, and we get 37.699. And then, of course, if they ask us to round it, we could say 37.70 and then centimeters. And remember, circumference is your outside boundary. It's a length, and so you're just going to put the units because it's a distance. All right, and then let's go ahead and look at area. So for area, we're going to do something similar. We have pi, and then we have 6 as our radius squared. 6 squared is 36, and then we're going to leave that pi on the end. 36 pi would be our exact answer, or answer in terms of pi. And then we're going to go ahead and throw that in the calculator. So we have 36 times pi equals, and I get 113.097. And then from here, if they ask us to round maybe to the nearest tenth, we would put 113.1. And then don't forget your units. Area is going to be your unit squared because we have 2 dimensions for area. Now let's take a look at what circumference and area might look like if they give us something on the coordinate plane. So for this one, we can't see the radius clearly. So if we look this way, we can't really tell what that point is. It is not in the corner of those boxes, so that's not something we can use. But they do give us 2 points on the circle. They give us the center, and then they give us a point on the outside. So this is the length that I want to calculate. I can either use my distance formula or I can use Pythagorean theorem. And if I'm using Pythagorean theorem, which I like the most because I think it's easier, it's actually just as easy as the distance formula, but I always feel like it's easier. So I create my right triangle. I have 2 and 2. And so if you do the Pythagorean theorem, we have a squared plus b squared equals c squared, and this turns into 2 squared plus 2 squared equals c squared, c being our radius, which is the hypotenuse right across from that 90-degree angle, and 2 squared is going to be 4 plus 4, so that gives me 8 equals c squared, and then from here I can take the square root of both sides and I get c is equal to the square root of 8. Now from here, this may be a point where you want to go back and review simplifying radicals, and this is also a special right triangle, so if you didn't get the pattern right off the bat, that might be something you want to look into reviewing as well. So with this one, I know that it's going to be 2 times the square root of 2, and 8 is equal to 2 times the square root of 2 when we simplify that radical. So now from here, I'm going to find my circumference, and if I'm doing my radius is 2 times the square root of 2. If I'm talking about my diameter is going to be 4 times the square root of 2. It's just going to be this times 2. And so when I'm doing my circumference, I might use pi d instead of 2 pi r. And if that's the case, it's going to be 4 times the square root of 2 pi. And then I could leave my answer like this in terms of pi, or I could put this into my calculator. If I go to put this in my calculator, I have 4 times 2 square root equals times pi equals, and I get 17.77. And if I needed to round this, I could do 17.8, and then there are no units on here, so I'm just going to put units. And then for area, same thing. I'm going to do, and in this case, I'm going to use that square root of 8 part that I had from down here. I have pi r squared. In this case, I have pi times the square root of 8 squared. And the reason why I use this is because I know that when I do the square of a square root, I'm going to get that same number. And so I would just get 8 pi. And I could leave it like that, or I could plug it into my calculator. Let's take a look at this problem. It says, find the diameter and radius of a circle when c is equal to 40 and round to the nearest hundredth as necessary. So for this one, I know that c is equal to 2 pi r, or I could say c is equal to pi d. And from here, that means that I would replace c with 40. And then to get r by itself, I'm going to divide by 2 pi. And so here, I would divide by 2 times pi. And then something very similar with this side here. I have 40 equals pi diameter. If I would want to get my diameter by itself, I would just divide by pi. And so for the diameter in terms of pi, I could leave it as 40 over pi. So in terms of pi, the diameter is 40 over pi. For this other one, I would want to treat this part as a fraction. So I have 40 divided by 2, and that gives me 20. And then pi is still going to be in the bottom. And that makes sense because the radius is going to be half of the diameter, and half of 40 is going to be 20. So we have 20 over pi, like this. And then if they asked us to use 22 over 7 for pi, that's all I'm going to do in my calculator. So remember, when you're using and you're dividing by a fraction, make sure you're putting it in parentheses. So in this case, for the radius, I have 20 divided by, and then instead of pi, I'm going to put parentheses 22 divided by 7, close parentheses, and then hit equal. And I got 6.363, and then of course we want to keep 2 decimal places because it asked us to round to the nearest hundredth. That 3 is not going to change the 6, and so it's just going to be 6.36. And then we would do the same thing for our diameter. And just keep in mind that our diameter should be about twice of what we got with the radius. So I'm going to go into my calculator again, and now I have 40 divided by parentheses 22 divided by 7, close parentheses, equals, and I get 12.73. And then just to do a quick check, you don't have to do everything all over again, but we have our circumference of 40 equals 2 pi, and then times what we got for the radius. And so just to kind of see if our answer is reasonable, 2 times 6.36 is going to give me about 13. And then 13 times 3 gives me 39 and some change, which is really close to 40. So this is a reasonable answer, and that's one way that you can kind of go about it. The same thing if I was looking at pi d, it would be this 12.73 times pi, which is 3 and some change, and that would give me something around 40. Looking at this question, it says find the area of a circle when the circumference is 9 and round to the nearest tenth. And so we're going to start out with our circumference is equal to 9, and then we need to go ahead and think about, okay, so what does the circumference mean? The circumference is going to be the same as pi diameter equals 9. And then I find the diameter to be 9 divided by pi. So if you need me to write it out, I'll write it out. So we're going to divide by pi on both sides, and that means d is equal to 9 divided by pi. And then from here, we can now find the area. So if they give you something, you can either find if they give you the circumference, you can either find the diameter or the radius, it doesn't matter. I know that the radius from here is going to be half of this, so it's going to be 4.5 divided by pi. And now looking at my area, because radius is something that I need, is going to be pi r squared. Pi times 4.5 over pi squared. And thinking back to what we did with exponents, don't let this freak you out. We have 4.5 squared. And so go ahead and type that into your calculator first. We have 4.5 squared, and that gives me 20.25. So I have 20.25 on the top. And then it's going to be over, because you're going to take the exponents and you kind of distribute them just like we practiced with our exponents unit. And so it's going to be over pi squared. And then don't forget this pi right here. And so that pi is going to be on the top. Well, I have a pi on the top and then I have these two pi's on the bottom. And so one of them is going to cancel out, or you could see it as an exponent of 1 minus 2 gives me -1, so pi is going to stay in the bottom. I get 20.25 over pi, like this. And so in terms of pi, we have 20.25 over pi. And then if they asked us to use 3.14, we would simply just do 20.25 divided by, if they asked us to use our pi button, or if they asked us to round from there, we would use this one. In this case, they're telling us to use 3.14, so divided by 3.14 equals, and I get 6.449. 6.449. It says round to the nearest tenth, so I want one number behind the decimal place. That 4 is not going to change that 4, and so this is going to go away. And because this is in units, we're going to say units squared, because they didn't say anything about what it looks like. They might also read it as 6.4 square units, so either way. And then this one here is going to be the same thing, units squared. Okay, we've got radius and diameter, area and circumference down. Now let's take a look at some intersecting circles. And so this kind of pairs together with what we learned with our segment addition postulate and working with segments back at the beginning of the year. And let's go ahead and take a look at what we have going on. So it says the diameter of circle L, don't forget that this is the symbol for circle, is 23 units. The radius of circle M is 7 units. And QR is equal to 5. What I'm going to do here is because I have a hard time looking at all of this stuff all together. And it kind of gets messy because I don't have a lot of room to put my work. And when I'm doing a test, I may not write down everything. Like I may not create the circles and all that stuff while I'm working. I might just go ahead and recreate this. And so I have P, L, Q, R, M, and S. So especially if you're taking a computer-based test, you don't need to make the entire diagram all the time. It doesn't have to be perfect. Give yourself some room. Looking at this, it told me that the diameter of L is 23. That means that from here to here, it's going to be half of that, right? Because this is the radius. That makes this 11.5, half of 23. That also makes from here to here also 11.5. And then they already told us that QR is 5. I'm going to go ahead and put that in there. The radius of circle M is 7. So this piece here is 7. If this piece is 7, that means that from here to here is also 7. So that's something I'm going to put on here, like that. Knowing that these two pieces together, QR plus RM is 7, I know this has to be 2. And then going back to what I know about circle L, this piece to this piece, L to R, needs to be 11.5. And 11.5 minus 5 is going to give me 6.5 here. Now that I know each and every piece, it makes it a lot easier for going through and doing these. So L to Q is going to be that 6.5 units. RM is going to be 2 units. And be careful on LM, because LM is this entire piece here. So that means you need to add all of these together, which means that it's going to be this 11.5 from here to here, plus that extra 2. So that's going to be 13.5 units. And thinking about what we already knew about circle L and circle M, I knew that the diameter was 23, and if I cut that in half, that gave me that 11.5. For the circle M, for the radius, I had 7. That makes the diameter 14, and then that means I can kind of go back and check my work to see if it works out. And looking from here to here, that's going to be 14. And so this kind of works out, and I just want to make sure that everything is on the up and up. Now let's switch gears into talking about sectors and arcs. So we know that arcs are a portion of the circumference. So if I'm looking for the measure of arc UV, I'm looking for this portion of my circumference. So when I'm thinking about circumference, I know that circumference is 2 pi r, and then I want to multiply it by what portion I have for that arc. And so that means I'm going to put the degrees over my entire circle, which is going to be 360. So in this case, I've got 2 pi times my radius, 8, and then my degrees. Whenever you're looking at degrees, you either want to make sure you calculate it. In this case, we have a central angle here, and so I already know that this arc measure is also going to be 70 degrees. And so 70 over 360. The formula that I chose for circumference, I went ahead and used 2 pi r because it already gave me r here. If it gave me the diameter right off the bat, then I would have probably used the diameter. So use which formula it makes the most sense or makes it easy. Just make sure that you're plugging in the right number for either radius or diameter. All right, and so from here I'm going to plug in all of my numbers into my calculator just like we did before. So I have 2 times 8 times parentheses 70 divided by 360, close my parentheses, equals, and I get 3.1 repeating. I'm going to do second F to D, that's 3 1/9. Second ABC, and that gives me 28 over 9. So I'm going to write 28 over 9, and then don't forget your pi symbol because we didn't use that yet. So 28 over 9 pi. If they are asking me to round, I would just do that in my calculator. So I have 28 divided by 9, and then times that pi, equals, and then I could round from here if they asked me to round. So that would also give me 9.8. And then remember that this is a portion of our circumference, and so it would just be inches because that is our unit for this particular circle. All right, and then we're going to do the same thing with major arc USV. So major arc USV, remember anytime they're using 3 letters, it's going to be an arc that is more than 180 degrees. If it's a semicircle, they'll usually tell you, but if it's a semicircle, that one is really easy. It's just going to be half of whatever your circumference is. So for those, you don't really have to do a whole bunch. All right, and so for this one, I would do the same thing. I have 2 pi, and then times my radius, which is 8. And then we need to figure out our degree measure for this one. Well, if I know that there are 360 degrees in a circle, and this portion is 70 degrees, that means that this has to be 290 degrees. And so from here, I would put 290 divided by 360. If I had to find both of them, I could also just find the circumference and subtract what I had for this one, and it should give me the same answer. Now I'm going to go ahead and plug this into my calculator. I have 2 times 8 times parentheses 290 divided by 360, close parentheses, equals, and second f to d, second ABC, I get 1/16/9 pi, and then we would take that and I get 40.5. And if I add both of these together, it should give me about what I should get if I calculated the circumference using that radius. It might just be slightly off just because of the rounding. All right, now let's think about area. So area is going to be that same idea of taking the portion of what the entire area would be for the circle. So for the minor sector UV, that means that we're talking about this section of the circle. And so taking the minor sector, if we're thinking about area, area is pi r squared. And then we're going to do that portion of the entire circle, so degrees over 360. So pi 8 squared, and then we know that that smaller sector is 70 degrees over 360. And that's going to give me about 64 times that portion of my circle. So I have 8 squared times parentheses 70 divided by 360 equals second f to d, second ABC. I get 112/9 pi, and then of course I could put pi in and go through with rounding. For our major sector, it's going to be very similar. We have pi times that 8 squared times that 290 over 360. And that should be the rest of the area. So if I found the area of the entire circle, I could subtract what I got for the minor sector to find the major sector in this particular case. So I'm going to move that over, clear out my calculator. I have 8 squared times parentheses 290 over 360, close up my parentheses, equals, then second f to d, second ABC, and I get 464/9 pi. And then of course you could put in pi and round from there if you need to. Okay, finding the area of a sector And finding the length of an arc wasn't too bad when we knew the degree measures, because we could use what we knew about area and circumference and just take a portion of that, right? But with these, what if we have to kind of work backwards and they're asking us for the degree measure of RS versus the arc length? I want you to think about this in terms of a proportion. We've got 44 as an arc length out of my entire circumference. And my entire circumference is going to be 2 pi and then times r. And that is going to represent some degree measure out of 360. When we think about it as a proportion, it's a lot easier to kind of solve from here. So now we're going to cross multiply, and we end up with x times the circumference. So let's go ahead and figure out what that is first. Let's get out our calculator, clear it out. We've got 2 times 15.28 equals, and I get 30.56. And I'm just going to leave pi in there until the very end. And we've got x times our circumference equals, and then 44 times 360. And that gives me 158.40. If I want to get x by itself, I'm just going to divide by that circumference. Let's get out our calculator, clear it out, and I have 158.40 divided by parentheses 30.56 times pi, close parentheses, equals, and this is about the degree measure that we should get for this one. So 164.98, I'm just going to round that to 165 degrees. And so now this becomes 165 degrees. And now I can find the measure of this arc. I could subtract that from 360 to find the other arc going the other way. But this one, and because it's only with 2 letters, it's talking about the minor arc. So you're talking about the arc that's less than 180. And so this is going to be 165 degrees. If you could follow kind of what we did with the math, you're basically going to take your arc measure times 360, that's what gave us the top, and then divide by our circumference. And so that's kind of a shortcut way of doing it. Now let's go ahead and do the circumference with this one. They gave us the arc measure, or the arc length, and then they gave us the arc measure as 150 degrees, but now we're looking for the circumference. So we're going to set up that same proportion. We've got the piece of our circumference, which is 10.5, over the circumference of the entire thing, equals 150 degrees out of the entire 360 degrees. And so from here, it's super duper easy. We're going to cross multiply. So let's get out our calculator. We've got 10.5 times 360, and we get 3780 equals 150 degrees times the circumference, not Celsius. And then we're going to divide both sides by 150. and we get 25.2. And so that one was super easy based on what we already know. There are going to be times where they're going to ask you for radians instead of degrees. So I want to quickly go over how we convert between the two. So radians are basically when we're thinking about our unit circle, and in high school geometry you're doing the very basic, at least in Florida. The unit circle is something you're going to see more of later when you're doing higher level trigonometry, especially when you guys get into pre-cal. But basically, it's what happens when the radius is 1. And we kind of talked about that when we were talking about special right triangles and using 1 as kind of like our base number. And when we think about the radius being 1, that means that the circumference would be 2 pi times 1. So the entire circle, which is 360 degrees, would be the same as 2 pi. So 360 degrees equals 2 pi. And that's how they kind of talk about radians, and that's why it's called radians, because we're talking about the radius being 1. That would make 180 degrees pi. That would make 90 degrees, half of that, so that would be pi over 2. And so this is another way of talking about different measures instead of degrees, and using radians instead. So that's just a quick overview and intro to radians and degrees. All right, so multiplying by pi over 180 is going to get you from degrees to radians. And if you're used to doing conversions, especially in science, we notice that this is the same as 1. Pi and 180 are the same thing. So you're really just multiplying your number by 1. So you're not really changing it, but you're now able to change the unit. And so let me kind of show you what this means. So let's take 25 degrees and we want to change that to radians. I'm going to go ahead and write out the word degrees here. When you guys do conversions, whether it's for science or for math, we multiply, and this is the same as being over 1, by the way. So if you need to put that to kind of help you remember, then do it. And when I'm converting, what happens is I'm going to draw this out, and I want degrees to be on the bottom, because once it's on the top and the bottom, it can cancel out, just like how we do in math. Okay, and we think about 3x divided by 3, and because I have 1 in the top and in the bottom, it cancels out because it equals 1. That's kind of what we're doing here. And then we've got radians as our unit in the top, and pi radians is equal to 180 degrees. Now from here, when I multiply, I get 25 over 180 pi radians. And if I reduce that down, that's going to be 5 over 36 pi, and that pi is off to the side, it's not underneath, radians. Okay, and then the same thing happens when you're trying to go from radians to degrees. So let's say we have 5 over 6 pi and then radians, and I'm just going to write it out. You usually won't see it like this, but just for conversions. Okay, that means you want radians in the bottom, and then we want degrees in the top. And I know that pi radians equals 180 degrees. And so now for this, I'm going to have 5 over 6 times 180. And I get 150. And then notice how I had pi radians on the top and pi radians on the bottom, and now I'm just left with degrees. And so this would be 150 degrees is equal to 5 over 6 pi. So there is your quick little lesson on converting radians and degrees. And that concludes our video for area and circumference of circles, including parts of circles.